When adding an outdoor outlet, it's crucial to adhere to the National Electrical Code, or NEC, to ensure safety and prevent code violations. An article might not explicitly state every requirement, so understanding the underlying principles is essential. One common area of concern is cable securement within electrical boxes. The NEC mandates that all electrical boxes must have an approved method for securing cables entering the box. This is typically achieved using a cable clamp, which can be either an integral part of the box or a separate fitting installed to secure the cable. The purpose of a cable clamp is to prevent strain on the wire connections inside the box. Without a clamp, any pulling or movement of the cable could potentially loosen connections, leading to arcing, short circuits, or even fires. If a drawing or set of instructions omits the explicit mention or depiction of a cable clamp, it should not be interpreted as permission to exclude it. It's always best practice to install a clamp regardless, as they are relatively inexpensive and easy to install. Ignoring this requirement could result in a failed electrical inspection and, more importantly, compromise the safety of your electrical system. Beyond cable securement, ground fault circuit interrupter, or GFCI, protection is another critical consideration for outdoor outlets. The NEC requires GFCI protection for all 125 volt, 15 amps and 20 amps receptacles installed in readily accessible outdoor locations. A GFCI is a fast-acting circuit breaker that monitors the current flowing into and out of a circuit. If it detects an imbalance, which could indicate a ground fault where current is leaking to ground, it quickly trips the circuit, cutting off power and preventing electrical shock. Outdoor environments are inherently more susceptible to moisture, which increases the risk of ground faults. Therefore, GFCI protection is essential for safeguarding people from potentially lethal electrical shocks. Instructions that fail to emphasize the necessity of GFCI protection for outdoor outlets should be viewed with caution. If the existing circuit power in the outlet does not already have GFCI protection, you must either replace the existing breaker with a GFCI breaker or install a GFCI receptacle as the first outlet on the circuit, effectively protecting all downstream outlets. Understanding the specific requirements for outdoor outlets is vital for ensuring a safe and compliant electrical installation. Remember that the NEC is a living document constantly being updated to reflect new technologies and safety concerns. Therefore, it's always advisable to consult the latest edition of the NEC and to seek guidance from a qualified electrician whenever you're unsure about any aspect of electrical work. Failing to do so could result in code violations, safety hazards, and potential damage to your property. Here's a breakdown of key considerations for installing an outdoor outlet. Firstly, verify the circuit's capacity. Ensure that the existing circuit has sufficient capacity to handle the additional load of the outdoor outlet. Overloading a circuit can lead to trip breakers, overheating, and even fires. Consult the circuit breaker rating and the ampacity of the wiring to determine the circuit's capacity. Secondly, install a weatherproof box. Use a weatherproof electrical box specifically designed for outdoor use. These boxes are constructed from durable materials that can withstand exposure to the elements such as rain, snow, and sunlight. The box should also have a weatherproof cover to protect the receptacle when it's not in use. Thirdly, use weatherproof wiring. Employ wiring that is suitable for outdoor applications, such as Type UF or underground feeder cable. UF cable is designed to be buried directly in the ground and is resistant to moisture, sunlight, and physical damage. Fourthly, properly ground the outlet. Ensure that the outdoor outlet is properly grounded to prevent electrical shock. Connect the grounding wire from the outlet to the grounding wire in the electrical box, and then connect that grounding wire to the grounding system of your home. Fifthly, seal all openings. Seal all openings in the electrical box and cover with weatherproof sealant to prevent moisture from entering. This includes the holes where the wires enter the box and the seam between the box and the cover. Sixthly, use appropriate connectors. Use connectors that are specifically designed for use with outdoor wiring and electrical boxes. These connectors will provide a watertight seal and prevent moisture from entering the box. Seventhly, protect the wiring from damage. Protect the wiring from physical damage by running it through conduit or burying it underground at the proper depth. Conduit is a protective pipe that encases the wiring and prevents it from being damaged by impact or abrasion. Eighthly, test the installation. After completing the installation, test the outlet to ensure that it is working properly and that the GFCI protection is functioning as intended. Use a circuit tester to verify that the outlet is wired correctly and that the GFCI trips when tested. Ninthly, obtain necessary permits. Check with your local building department to determine if any permits are required for the installation of an outdoor outlet. Obtaining the necessary permits will ensure that the installation is inspected and meets all applicable codes and regulations. Tenthly, consult a qualified electrician. If you are not comfortable performing the electrical work yourself, or if you have any questions about the NEC requirements, it is always best to consult with a qualified electrician. A licensed electrician will have the knowledge and experience to safely and correctly install the outdoor outlet. Remembering that the NEC undergoes revisions periodically, staying current with the latest edition is crucial. The NEC is updated every 3 years, so be sure to reference the most recent version adopted by your local jurisdiction. These updates may include changes to the requirements for outdoor outlets, GFCI protection, and other electrical installations. Another crucial aspect of electrical safety is understanding the ampacity of conductors. Ampacity refers to the maximum amount of current, measured in amps, that a conductor can safely carry without exceeding its temperature rating. The NEC provides tables that specify the ampacity of different types of conductors based on their size, insulation type, and installation conditions. When selecting wiring for an outdoor outlet, it's essential to choose a conductor with an ampacity that is sufficient to handle the anticipated load. Overloading a conductor can cause it to overheat, which can damage the insulation and create a fire hazard. The NEC also addresses the proper sizing of overcurrent protection devices, such as circuit breakers and fuses. These devices are designed to protect electrical circuits from overloads and short circuits. When selecting an overcurrent protection device, it's important to choose a device with a rating that is appropriate for the ampacity of the circuit conductors. An overcurrent protection device that is too large will not provide adequate protection, while a device that is too small will trip unnecessarily. Furthermore, understanding voltage drop is crucial for ensuring proper operation of electrical equipment. Voltage drop refers to the reduction in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause electrical equipment to malfunction or operate inefficiently. The NEC provides guidelines for limiting voltage drop in electrical circuits. When designing an electrical circuit, it's important to consider the length of the conductors and the amount of current that they will be carrying. Longer conductors and higher current loads will result in greater voltage drop. In addition to these technical considerations, it's also important to be aware of the administrative requirements for electrical work. Most jurisdictions require electrical permits for certain types of electrical installations, including the installation of outdoor outlets. Obtaining an electrical permit ensures that the work is inspected by a qualified electrical inspector to verify that it complies with the NEC and other applicable codes. Electrical inspectors play a vital role in ensuring the safety of electrical installations. They are responsible for reviewing electrical plans, inspecting electrical work, and enforcing the NEC. If you are planning to perform any electrical work, it's important to contact your local building department to determine if an electrical permit is required. In addition to the NEC, there may be other local codes and regulations that apply to electrical installations. It's important to be aware of these local requirements and to comply with them. For example, some jurisdictions may have specific requirements for the type of wiring that can be used in certain areas or for the location of outdoor outlets. Failure to comply with local codes and regulations can result in fines or other penalties. When working with electricity, it's always important to take precautions to protect yourself from electrical shock. Always turn off the power to the circuit before working on it. Use insulated tools and wear rubber gloves and shoes. Never work on electrical equipment when you are wet or standing in water. If you are not comfortable working with electricity, it's best to hire a qualified electrician. A licensed electrician will have the knowledge and experience to safely and correctly perform the electrical work. When choosing an electrician, be sure to check their credentials and references. Ask for proof of insurance and licensing. A reputable electrician will be happy to provide this information. Remember, electricity can be dangerous if it is not handled properly. By following the safety guidelines outlined in the NEC and by taking precautions to protect yourself from electrical shock, you can safely perform electrical work and ensure the safety of your home and family. It is crucial to distinguish between doing what is easiest and doing what is safest and compliant with the NEC. Shortcuts or deviations from established safety practices can have severe consequences. Always prioritize safety and compliance above all else. Electrical safety is not merely a matter of following rules, it is a matter of life and death. Take the time to learn about electrical safety and to follow the guidelines outlined in the NEC. Your safety and the safety of your family depend on it. When in doubt, always consult with a qualified electrician. They can provide expert advice and guidance to ensure that your electrical work is done safely and correctly. Remember that electrical codes and regulations are constantly evolving. Stay informed about the latest changes to the NEC and other applicable codes. This will help you to ensure that your electrical work is always up to date and compliant with the latest requirements. Lastly, regularly inspect your electrical system for any signs of damage or wear. Check for loose wires, cracked insulation, and other potential hazards. If you find any problems, have them repaired immediately by a qualified electrician. Regular maintenance can help to prevent electrical problems from occurring in the first place. By following these guidelines, you can help to ensure the safety and reliability of your electrical system.